Hello, my dear students. Very good afternoon to everyone. Hello, dear students. Good afternoon. Very good afternoon, my dear students. Hope the video is clear and the audio is also clear. Good afternoon, Aishwarya. Sidhu, very good afternoon. Is the video clear? Audio? Can you hear me properly? Good afternoon, Aditi. Okay, Sidhu. Thank you. Let's see who all have come. We have two check-ins as of now. So dear students, please hurry up because we are having only half an hour time. So now let me just progress to the uh, beginning part of my class. Dear students, my name is Uttam Kumar Umarji. I'm an MTech graduate. I'm your personal physics teacher on Unacademy. And I have a total of 19 years of experience in teaching various students all across India. I have taught so many students all across India presently. And presently, I'm working at Prarthana College in Karnataka. Now, let me just move on to what Unacademy has to offer to each one of you, my dear students. So, right now, here, my dear students, I'll be introducing you to the Unacademy Plus subscription plan. To begin with, we have Unacademy Plus subscription plan that is specifically planned for Karnataka CET 2021, and the best plans that can be offered, best in the market, okay, are first one is a 12-month plan that will cost you 12,375 rupees, and a 6-month plan that will cost you 10,125 rupees, and 12-month plan, my dear students, you can get it at a cost of around 1,031 per month, and 6-month plan, it works out to be around 1,700 rupee per month. So obviously this is highly beneficial thing for you. And thirdly, we have a 1 month plan, which is a trial plan for you. And this is for new subscribers only and only for new subscribers, those who have not subscribed, for them. Then what we have a comprehensive batch already in progress. One batch has started day before yesterday, that is on 16th of this month, my dear students. So you can go ahead and avail benefits by going through any one of these plans, okay. And then dear students, as you all can see here, what we can offer, at Unacademy. We can offer you a premium content at affordable price, structured live courses, dedicated live doubt clarification sessions, and quizzes are at regular intervals for self-analysis. Then batches for complete preparation that we have. Then test series for DPPs, full length mocks. Everything will be provided with analysis, pin to pin analysis, my dear students. And lastly, I would like to say a single subscription for unlimited access. This is the most important thing. Okay, you will get unlimited access here, my dear students, and you can use Uttam Live as your code to avail a 10% discount on any of these subscriptions, my dear students. So remember the code, it is Uttam Live. This is the referral code, okay, that you can use to avail a 10% discount straight away, my dear students. So what if you can get multiple calls from various institutions all across Karnataka after KCET 2021? So obviously that is promised by an academy. You can go ahead and grab this opportunity. Okay, now today's discussion as such, my dear students, I'll be going ahead with fluid dynamics, the introductory part of fluid dynamics, my dear students. Okay, so let me just go ahead and take a look at some of those intermittent things that we have right now. First thing, we'll talk about fluid flow. Okay, so what kind of flow a fluid can have? So there are two kinds. First one is a streamline flow, second is a turbulent flow, and in between streamline and turbulent there is a transitional flow. And we can say a streamline flow is a flow of liquid in which each element of each element of the liquid passing through a point travels along the same path and with same velocity as the preceding element passes through that point. So obviously here, as you can notice in this diagram, my dear students, now at point A, velocity is v1. At point B, velocity is v2. At point C, velocity is v3 here. Now, any liquid molecule or any liquid particle, if it comes at point A, that will possess a velocity of v1 only. Okay. Similarly, when the same liquid molecule or particle reaches point B, its velocity will become v2. And in the same way, when the same particle reaches point C, then its velocity will be v3. And not only that molecule, every molecule or every particle of that liquid, when they pass through A, B and C, they will possess the velocities as v1, v2, v3 only. So then that kind of flow is called as what? Streamline flow. Okay, so that is what I'm mentioning here in the definition. Okay, now let's progress to path ABC. Now this path ABC is a streamline. As you can see here, path ABC is called as a streamline. Okay, and v1, v2, v3 are the velocities of the liquid particles at A, B and C respectively. Okay, so this is regarding streamline flow. Second special case is a laminar flow. Now, laminar flow, what it does? Laminar flow, if a liquid is flowing over a horizontal surface with a steady flow and moves in the form of layers of different velocities which do not mix with each other, then the fluid flow is called as laminar flow. Okay, so that means we can say that a liquid is flowing over a horizontal surface. This is first condition with a steady flow. Okay, and moves in the form of layers of different velocities which do not mix with each other, then it is laminar flow, my dear students. Okay, so now in this particular flow, what happens over here is the velocity of liquid flow is always less than critical velocity of the liquid. Okay, this is one point. And second, the laminar flow is generally used synonymously with streamlined flow. Remember this. Laminar flow is usually, we call it as a streamline flow only, but I would suggest that laminar flow is a special type of streamline flow. Okay, fine. Next thing would be turbulent flow. So what is turbulent flow? Now, when a liquid moves with a velocity greater than its critical velocity, the motion of the particles of liquid becomes disordered or irregular. Such flow is called as a turbulent flow. Okay, so now turbulent flow, usually what we will have when a liquid moves with a velocity greater than its critical velocity, the motion of the particle of the liquid becomes disordered or it becomes irregular. Then it is called as what? A turbulent flow. Okay. So this is most important thing that you should always remember. Okay. Now, after this, we should understand regarding the turbulent flow nature. Now, as you can notice here, in this particular region here, we have a streamline flow and slowly the liquid particles or liquid layers are moving in different directions, as you can see here. Okay, and slowly they will form the vertices. Okay, vortex. So this is a pillar. This is a pillar here. So you please remember this. This is a pillar, as you can notice. Okay, so suppose this is a river. Now river water is flowing and here there is a pillar of the bridge, and you can notice that the river water forms eddies here. Now these are called as eddies. These are called as eddies. Okay, it will form eddies. Please remember this. So eddies are formed, and by the virtue of that, the turbulency will begin. Okay, so hence we can say in a turbulent flow, path and velocity of the particles of the liquid change continuously and haphazardly with time from point to point. Okay, so whereas similarly, and in a turbulent flow, most of the external energy maintaining the flow is spent in producing eddies in liquids. Okay, and only a small fraction of energy is available for forward flow. As you can notice here, only small portion of liquid molecules are moving forward, whereas rest of them are involved in forming the eddies here. So that is what we can notice over here. Then we can see the example as I have shown in the diagram. This is eddies are seen by the sides of the pillars of a river bridge. Okay, so as you can see, this is a pillar. So at the pillar, eddies are formed. Okay, fine. Now here is a comparative description on laminar flow. Okay, now laminar flow is a straight line path, as you can see here. This is laminar, whereas here, let me just erase this off. Okay, whereas as you can notice here, in transitional, which is in between laminar and turbulent, this is called as transitional. Okay, so in between laminar and turbulent, we have a flow called as transitional flow, and transitional flow looks like this. Okay, in two dimension, and turbulent flow, as you can see here, the liquid particles are moving randomly in vague direction, so their directions are totally different here. Okay, so this is what we can make out by using this particular sketch. Okay, now let me just show you one more important thing here, that is, in this particular picture, as you all can notice, now this region is laminar region. Okay, as you can see, the water is also quite plain and coming forward, and entire set of molecules are in the same direction. Okay, whereas here in between these two there is a transitional phase. Now this is transitional. Okay, and this is turbulent, my dear students. This is turbulent flow. Okay, so this is how we can comfortably understand regarding the flows that we have. I hope it is clear to you all. Now let me just move on with my next part, that is critical velocity and Reynolds number. These are two things that we'll try to understand now. Now, critical velocity. Okay, the definition of critical velocity is the velocity of liquid flow up to which its flow is streamlined and above which its flow becomes turbulent. Okay, so critical velocity is that velocity of liquid up to which its flow is streamlined and above which its flow becomes turbulent. Okay, so hence we should remember this point here: velocity of liquid flow up to which its flow is streamlined and above which its flow becomes turbulent. Okay, so that is critical velocity, my dear students. Okay, now let me just talk about Reynolds number after this. Now what is Reynolds number? Reynolds number is a pure number which determines the nature of flow of liquid through a particular pipe. Okay, so now over here, definition can be very simply mentioned as the ratio of inertial force per unit area to the viscous force per unit area. That is, it is the ratio of inertial force per unit area, to the viscous force per unit area. So now over here you can clearly understand what is force per unit area. Is it not pressure? Right? So inertial force per unit area, that is pressure due to inertial force, that is pressure due to weight, mass. Okay, so these all things. And viscous force per unit area is what? Pressure due to viscosity of that liquid. Okay, now these are two things that we will involve in defining a Reynolds number. So hence we can say NR, that is Reynolds number, NR is equal to inertial force per unit area divided by viscous force per unit area. Okay, thus we can write this Reynolds number in another form. So I'll recall back this particular statement here. I'll write this as inertial force per unit area. I'll write it as V square rho into V square, that is inertial force. Now rho involves what all things? It involves mass, okay, divided by volume. Mass per unit volume is density. So obviously here mass term is that inertial term. Okay, so that is why velocity of the body or velocity of the liquid square into mass, so rho into V square, so that is obviously inertial force per unit area it is, okay, divided by eta, that is coefficient of viscosity, into velocity of the liquid into radius of the pipe. Okay, so this is viscous force per unit area, my dear students. Okay, so that I'll get Reynolds number equal to what? Nr is equal to V rho R divided by eta. So this is Reynolds number, my dear students. Okay, I hope it is clear. Now let me just progress to the next part quickly. Now, what are the requisite values to define a flow? Because Reynolds number is a number which is used to define the nature of a flow of a liquid. So, if the value of Reynolds number lies between 0 to 2000, the flow is streamline or laminar. Okay, and if the Reynolds number lies between 2000 to 3000, the flow of liquid is unstable and it is changing from streamline to turbulent. Okay, and here above 3000 the flow of liquid is definitely turbulent. So please remember these numbers. Okay, 0 to 2000 it is streamline or laminar, then 2000 to 3000 it is unstable and changing, that means it is transitional. Okay, and above 3000 the flow is turbulent. Okay, fine. So this is regarding Reynolds numbers values. Okay, on the basis of these values we can comfortably understand what kind of flow a liquid can have. Okay, is this clear, my dear students? Now let me just progress to the next part quickly. Equation of continuity. We'll just talk about equation of continuity here. Now, the equation of continuity is another statement of conservation of mass, my dear students. Okay, so over here, if I consider a pipe of varying cross section like this, where one end has an area A1, another end has an area A2, and I'll consider velocity of the liquid at end A as V1, okay, and velocity of the liquid at end A as end B as V2, okay. Then density of the liquid, if I take it to be rho only, then we tend to see that mass of liquid entering per second at A is equal to mass of liquid leaving per second at B. Now this is continuity equation statement. Okay, so is it not conservation of mass here? So mass of liquid entering per second at A is equal to mass of liquid leaving per second at B. Okay, then we can comfortably write here A1 V1 rho 1 is equal to A2 V2 rho 2. Okay, so accordingly, if the liquid is incompressible, then density will not change. So obviously rho 1 and rho 2, both of them should be equal to each other. So from that I can write finally A1 V1 is equal to A2 V2. Now this is continuity equation, my dear students, and remember this is the statement of continuity equation, and finally I can write it as AV is equal to constant, that is product of area and velocity is equal to constant, or area is inversely proportional to velocity, or velocity is inversely proportional to area. And one more thing, A into V, it is called as rate of discharge, Q. Okay, A into V, which is nothing but volume of the liquid per unit time. Volume of the liquid per unit time. Just rewrite it properly. V divided by volume by time is A into V here. Okay, so please remember this is equal to A into V. I hope this part is clear to everyone. Now let me just progress to the graph between area and velocity. Now, as we know that area is inversely proportional to velocity, or velocity is inversely proportional to area. So obviously it must be a rectangular hyperbola. As you can notice here, this is a hyperbolic curve that we have, my dear students, as we can notice here. Okay, so this is the variation graph. So here we can write A is inversely proportional to V. A is inversely proportional to V here. Okay, so this is principle of continuity, my dear students. Now, with this particular note, I am very much obliged and thankful to everyone that this YouTube session became such a successful thing for your grand appearance into the audience. Okay, so thank you very much for watching this class, and stay tuned, stay subscribed to Unacademy Plus. Okay, in order to get a complete plus subscription with 10% discount, use Uttam Live, UTTAM, Uttam Live. Now this is highlighted here, so you just please remember this code and get a 10% discount out of it, my dear students. So with this note, I'm closing today's session. Okay, so let us meet back in the next session with YouTube Live. Thank you, one and all. Have a wonderful time. Stay connected, stay tuned, stay safe. I'll see you in the next class on YouTube Live. Thank you. Bye then.